Exercise 7D, determining transformations. So we have been able to apply a set of transformations, but now what we need to do is to have the skill that if I have the original template, I have the final answer, you need to be able to describe what has happened. A systematic approach will help, and then from there we can go and describe what has happened. When we're describing transformations, we must use the official mathematics terminology. We can't just say, oh, it's shifted to the right, shifted up a bit. No, we can't have that. We will be saying it's translated into the positive direction or translated into the negative direction, and we're saying it's dilated from. We don't want to be ending up saying things like, it's stretched a bit, squashed by. No, we use the official terminology. So let's get started. Example 7D.1. For each of the following, find a sequence of transformations that takes the graph of y equals square root x to the graph of y equals square root x plus 3 plus 2. For this particular equation, what I would suggest that we want to do is we will have a systematic approach to describe what has happened. We've started with our x and y from the original, and what's happened? Well, we can describe here that x has moved 3 to the left and 2 up. And thus we can describe it accordingly. But how did I get that? How did I find that original answer? How was I able to determine that? Well, we can actually use our transformation statements to help us out. So, if you like, if we were to go and think of it this way, what I'm going to do is I want to get a statement such that y equals something and x equals something. So, what we're going to do is rearrange this original equation such that we can do that. So I know that y, if I was to minus 2 on both sides, I get y is equal to, or y, the transformed y minus 2. So that's what the y's would look like. What would the x's look like? Well, the x's here are going to look like the transformed x plus 3. So now what I'm going to do is rewrite these to go and describe the transformations. Because remember, this is the x transformation. That's the y transformation. So if I was to go and write them accordingly, we have our transformations. So what did I do there? I went and rewrote the y and x in the equation as the transformed versions of those. I then rewrote the equation such that I was able to find out what the originals would be. I rearranged them such that y dash or y apostrophe is the subject, and then I can just fit that back into the original equation. So how would we describe that? We would describe that it has been translated 3 units in the negative x direction, translated 2 units in the positive y direction. And in this instance, it doesn't matter which one, if you say the x is first or the y is first. Both are perfectly fine. Y equals 2 root 3, square root 3x. So again, I'm going to just label those accordingly. And I'm going to set up a transformation statement. So there we've written our transformation statements there. So I divided, remember I needed to get what the y would be equal to. So the original y, to get the original y to the transform one, we divided by 2. I've rejigged the transformation there. And then for the x's, the x here, the original, what we substituted for the original would have been 3x. So then I rearranged it for the transformed version. And so what this would look like is something like this. So it's been dilated. So it's been dilated by a factor of a third from the y-axis, dilated by a factor of 2 from the x-axis. Again, all I did was basically work in reverse of the previous examples. I've labeled these x and y's as the transformed versions. And what I'm doing is I'm writing that the original, to transform into that, had to be y apostrophe over 2. Why is it over 2? Because I had to divide this on both sides to get that 2 on the other side. And then we had the x's here. X is equal to 3x apostrophe. So I would have had to substitute the original x to 3x. And so if I divide both sides by 3, I've just got the transformed version of its own. And that will tell me what will go inside these particular brackets. With the next one here, we can see we've got a translation of 2 units in the positive y direction. We've also got a reflection as well. The important thing is knowing the sequence of transformations that have occurred. So it has been reflected in the x-axis, and then it has been moved up by 2. Now, what would have happened if I had said it the other way around? If I had gone and said that it was moved up by 2 and then reflected, it would have ended up becoming, so it would start by, we'd have y plus 2, and then that would have become x brackets negative y plus 2. And then suddenly that would become negative y minus 2. So it would have been going down, which is not what's happened here. It has been moved up. So this is another example where this sequence of transformations is very important. So here we are saying that it's been reflected in the x-axis, translated 2 units in the positive y direction. We can still do this as the systematic way, or confirm what we've done by using the transformation statements. And thus there is our set sequence of using the systematic approach that will get us to our transformations. Example 7D.2. Find a sequence of transformations that will take the graph of y equals 5 over x minus 3 squared minus 7 to the graph of y equals 1 over x squared. Now this one is it's very much a challenge, because often the rookie mistake, and I have made it several times, is that we're used to going from here to here. So taking the original or taking a sort of a template version and moving it into something like this, whereas actually what we want to do is we want it to go into this direction. The first thing I would do is, much like the other ones, label the transformed versions and then try to match them up with the equations on the left. So the first thing I've done here is I've said that the transformed y is equal to y plus 7 over 5. Now, how did I get that? What I did was I added 7 to both sides of this equation on the left, and I divided everything by 5. Because essentially, to be able to get from this equation back to this one, I would need to add 7 and divide by 5 to get it to look even remotely like the truncus on the right. As for the x's, what we're going to need to do, what's happened here? Well, this is x minus 3 squared, so that's move 3 to the right. So we're going to need to move it 3 to the left to be able to get back to our 1 over x squared. So now we just need to substitute or put this as a statement. So now that we have written the systematic XY notation, what we're going to do is we're going to write this as statements. So it's been translated 3 units in the negative x direction. And now for the dilation. Now we've dilated by a factor of 1/5 from the x-axis, then translated 7 units in the positive y direction.